Hello students, welcome to my class. In my last lecture, I was discussing about the theories related to this chapter. This is one of the most important chapter related to your syllabus. This chapter actually contains three important chapters: chemical equilibrium, ionic equilibrium and acid, bases and salts. Clear to you? So today what we are doing, we will solve few questions related to this chapter and definitely my friend will boost your knowledge. So let's start the question answer round. Okay, now let's move to the question number 1. What is given here? Look at. The question is, explain why pure liquid and solid can be ignored while writing the equilibrium constant expression. For example, if I write here CaCO3, it gives you CaO plus CO2. Am I right? Yes. If anyone asks you to write the equilibrium constant expression, clear? Then what to do in this case? That is, we will write here Kp is equal to partial pressure of CO2, the best way. Or if anyone asks you in terms of Kc, you will write here concentration of CO2. Why not this one and this one? Because the concentration was taken as 1. Now the question arises, why the concentration was taken as 1? Clear to you, my friend? I am moving here, check it out. As we know, concentration is equal to what? Mole per liter. Yes sir, definitely it is mole per liter. Now what is mole, my friend? Mole is equal to given mass upon molar mass. Yes sir, you are absolutely correct. That is W upon M. And what is liter? That means to say that is mole upon volume. Yes. Now put this value here. What we get here? Concentration is equal to W upon M into V. Yes sir. Now we people know W upon V is equal to density. Am I right? Yes. So what the term here? We get density upon molar mass. As we know, for solid and liquid, density is fixed. Density is constant and we know molar mass is also constant. So this term is overall constant. So there is no variation. Due to this reason, we take the concentration of solid and liquid during writing the expression of equilibrium constant equal to 1. Am I right? This is a complete explanation related to this question, my friend. Let's move to the next one. What is given here? Now, the question number 2. Look at the question. Read the question carefully. Am I visible? Yeah. Predict if the solution of the following salt are neutral, acidic and basic. As we all know, salts are of 3 types. Yes sir. Acidic salt. Yes sir. Basic salt. Definitely. And that is neutral salt. Am I right? Yes. When there is a formation of acidic salt take place, as we know, when acid and base combine, they form salt. If the acid is strong and base is weak, then we get acidic salt, my friend. Now what about the basic? If the base is strong and the acid is weak, then we get basic salt. Yes sir. And neutral salt, if the acid is strong and the base is also strong, we get the neutral salt. Or if the acid is weak and the base is also weak. Clear? Now find out. NaCl comes from NaOH plus HCl. As we know, NaOH is strong and HCl is strong. Both NaOH and HCl is strong. So what will you say? That NaCl is an example of, my friend, neutral salt. Am I right? Now the next one, KBr. KBr comes from KOH plus HBr. But one more thing I am telling here, in comparison to KOH, KBr is less acidic, my friend. That is, this one is strong and this one is weak. In many book it is given that HBr is strong, but HBr, HI is strong, not HBr, my friend. So in this case we will tell that is base, so strong base, this salt is basic salt, my friend. Again I am repeating, this salt is basic salt, KBr. Now wait for a moment. Now NaCN, NaOH plus SCN. This is again basic salt because NaOH is more powerful than SCN. So this is the example of basic salt, NaCl. Now NH4NO3. NH4 comes from NH4OH and NO3 comes from HNO3. We know nitric acid is strong acid and NH4OH is weak base. So this one is strong acid, weak base. So we will tell that acidic salt is NH4NO3. NH4NO3 is acidic salt. Now what about NaNO2? As we know, NaNO2, NaOH plus HNO2. Nitrous acid is not so much strong, but NaOH is strong. So NaNO2 is a salt of strong base and weak acid, my friend. That is, we will put here NaNO2. Am I right? Yes, sir, you are absolutely right. And what about KF? KF come from KOH and HF, my friend. Again I am telling that is KOH is strong base but HF is not a strong acid. So the answer will be basic salt, my friend, that is KF. This is the case. Acidic salt NH4NO3, neutral salt NaCl, and what about the thing rest is, my friend, basic salt. Am I right? Yes, sir, you are absolutely right here. Now I am going to rub this part and we'll discuss the next question. Wait for a moment. Now what is the next question here? Read the question carefully. At a certain temperature and total pressure of 10 to the power 5 Pascal, okay, iodine vapor contain 40% by volume of iodine atom. 40% by volume of iodine atom. Calculate Kp for the equilibrium. Yes, definitely. Kp for the equilibrium. That is, we have to find Kp is equal to, this is iodine, that is, my friend, Kp is equal to partial pressure of atomic iodine square upon partial pressure of I2. Now the question here, partial pressure of iodine and partial pressure of atomic iodine will be, here is given iodine vapor content 40% by volume of I atom. So the partial pressure, suppose iodine will be equal to 40% and total pressure is given 10 to the power 5 multiply 40 upon 100, and partial pressure of I2 will be equal to 10 to the power 5 multiply 60 upon 100. This is the case. Now put this value here. What we get here, 10 to the power 5 into 40 upon 100, clear, then 10 to the power 5 multiply 40 upon 100. Am I right? Yes, sir, you are absolutely right. Divided by Pi2, this is 10 to the power 5 into 60 upon 100. Clear? Now it is very simple. This will cancel this one cancel. Again, next one, 10 to the power 5, this one will cancel this one will cancel this one. What we are getting, 2, 2, 4, 2, 5, 10, that is 2 by 5 to 2, 4, 2, 5, 10, 2 by 5 into 2 by 5 into 10 to the power 5 divided by that is 236, 2510 divided by 3 upon 5. Am I right? Yes, sir. Now this 5 and this 5 will cancel each other. What we are getting, that is 4 into 10 to the power 5 upon 15, my friend. This is the case. This is a simple method to find out the Kp for the equilibrium. Is it clear? Now check it out the solution here. That is the partial pressure. Partial pressure is equal to total pressure multiply mole fraction. Total pressure multiply mole fraction. 40% here is given by volume of iodine atom. So 40 upon 100, and for I2 for 60 upon 100, because total is 100. This is the case. Put here I 10 to the power 5 into 40 upon 100, 10 to the power 5 into 40 upon 100 divided by 10 to the power 5, 60 upon 100. After solving, you can get the answer. Am I right? Yes, sir, you are absolutely right. I am going to rub this part, my friend. I will discuss the next one. Let's move to the next question. What is given here? This is the question. Read the question. Find the value of Kc for the following equilibrium, equilibria from the value of Kp. As we know, if you have data that Kp, Kp and Kc, we know is very simple. Yes, sir. Do you remember? Yes, sir. Kp is equal to Kc RT to the power delta n. Do you remember this? Yes, sir. What is delta n? It's not delta n, it is delta Ng. Delta Ng, number of moles of the gaseous reactant and minus number of moles of the gaseous, number of moles of the gaseous product, right side, minus number of moles of the gaseous reactant. So what is delta Ng, my friend? Yes, 2 plus 1, 3 minus what is 2, that is delta Ng is equal to 1. Am I right? Yes. Now we can write here Kp is equal to Kc RT to the power 1. Am I right? Yes. Kp upon RT is equal to Kc. Now we have the answer. What is Kp? Put the value. That is 1.8 into 10 to the power minus 2. What is R? We know R is equal to 0.0821 liter atm per mole per Kelvin. What is temperature? That is 500 Kelvin. Put Kc. Now you solve, you will get the answer. This is the output. A simple question. Kp is equal to Kc RT to the power delta Ng, and delta Ng is equal to, again I am repeating, number of moles of product minus number of moles of reactant. 2 plus 1, here is 1, nothing, that is 1. 2 plus 1, 3, 3 minus 2, that is 1. Put this value, you will get the answer. Am I right? Yes, sir. Now I am going to rub this part, my friend, and we will discuss the next question. Now what is the next question? The next question here is question number 5. This is a big question. Now first of all, read the question. At 450 Kelvin, I am writing the data here. Question number 5, 1. Now at 450 Kelvin, Kp is equal to, Kp is given here 2 into 10 to the power 10 bar. Okay, sir. For the given reaction, what is the given reaction? 2SO2 plus O2. Yes, sir. It gives you 2SO3. Yes, sir. This is the reaction. What is the Kc at this temperature? Now, my friend, it's your turn. How to find the Kc? How to? 5 seconds before I have discussed this type of question. As we know, it's very simple. Listen. As we know, Kp is equal to Kc RT to the power delta n. Yes, delta n, that is delta Ng. Remember? Now what is delta Ng, my friend? Tell me. Number of moles of gaseous product. 2, yes, minus 2 plus 1, 3. That is minus 1. Am I right? Yes, sir. Now we know the value Kp. Kp is equal to Kc RT to the power minus 1. Yes, sir. That means to say Kp is equal to Kc upon RT, or we can say Kc is equal to Kp RT. Yes, sir. Now put the value. What is Kp according to the question? Kp is given 2 into 10 to the power 10. R we know 0.0821. Temperature 450. Everything you have. You put the value 2 into 10 to the power 10. R is equal to 0.0821 and temperature is 450 Kelvin, my friend. Now what we have? We have the answer. What I am telling, my friend, question may look tough, but it's not so tough if you have the command over the theory. Look at very systematic order. No need to explanation, no special theory I am including here, just putting the normal data. Okay. Now I am going to rub and we will discuss the next question, my friend. Wait for a moment. Now, what is the second part of the question here given? The second part, read the question first of all. At 700 Kelvin, the equilibrium constant for the reaction, this is the equilibrium constant, okay, is 54.8. For this reaction, this is the value. So, what we have the value of equilibrium constant, that is 54.8, okay. Now, if 0.5 mole per liter of HI is present at equilibrium, equilibrium is given, okay. What is the reaction here? That is H2 plus I2, that is the case, my friend. H2 plus I2, yes sir, it gives you, that is 2HI. Clear, my friend? Now the question is, what are the concentration of H2 and I2? Assuming that we initially start with HI, look at, my friend, what is given. We started with HI, that is we need to reverse the reaction. That is now the reaction is 2HI, which gives you, my friend, H2 plus I2. Now this is the reaction. Now remember the theory. If we reverse the reaction, so the new K dash C will be the reciprocal of this one, old one. Remember? So what will happen? K dash C is equal to 1 upon 54.8. This is the case. Now, this is not the end. Again in question given at equilibrium, the concentration of HI, look at, is 0.5. Clear? Given. Now this one is X and X, and we have to find the concentration of H2 and I2, that is the value of X. Am I right? Now we have reached the output. Now tell me, what is the expression for nu K dash C? Nu K dash C, concentration of product upon concentration of reactant. Yes sir. What is the product concentration? X into X upon reactant concentration, that is 0.5 to the power 2. Yes sir. Now what is K dash C? Yes sir, 1 upon 54.8, because we are reversing the reaction. Now what will happen? X square upon 0.5 into 0.5. Yes sir, 0.5 square. Now what to do? We will put here, sir, X square is equal to 0.5 into 0.5 upon 54.8. Am I right? Yes sir. Now X is equal to root under, is it visible? Wait for a moment. Is it visible to you? 0.5 into 0.5 multiply by 54 point, I'm moving here. So what we find, X is equal to root under 0.5 into 0.5 divided by 54.8. Am I right? Yes. We can write here assuming 0.5 into 0.5 upon 54.8. Clear? Now we know the root of 0.5 into 0.5 is 0.5. Now here is 54.8, no exact root, but this value lies between 7, the root of 7 and 8, because the root of 49 and the root of 64 is 7 and 8, and this value 54.8 lies between this quantity. Am I right? So the root value lies between 7 and 8. So we can conclude that the value may be, that is the estimation my friend, not a complete calculation. You can calculate in your home, but the values 49 and 54, that is the value lies between around 73.35. You can put this value, this is the value, that is the approximation, this is the value of x. Am I right? Yes sir, you are absolutely right. So x is equal to, we can write here 5 upon 74. So what is the question here? What is the concentration of H2 and I2? Concentration of H2 is equal to x is equal to I2 is equal to 5 upon 74. This is the case my friend. Calculation easy, but what is the theory involved here? That is two theory I am going to discuss here. That is, when we reverse the direction of the reaction, so old Kc is the reciprocal, the new Kc is the reciprocal of old Kc. Clear to you? And what is the concentration? Equilibrium concentration, that is x value. Am I right? Yes sir, you are absolutely right. Now I am going to rub this part my friend, and we will discuss the next part of the question. Wait for a moment. The next question. Now, what is the next question here? Question number 6. Read the question. I am giving you a time. Read the question. Kp is given 0.04 atm at 899 Kelvin for the equilibrium given below. What is the equilibrium concentration of C2H6 when it is placed in a flask at 4 atm pressure and allowed to come to equilibrium? Okay, we need to find the equilibrium concentration, but is given is pressure. Am I right? Yes sir. Now what is the expression? Solution of this question. This is one of the best question. C2H6, this is in a gaseous state. It gives you my friend C2H4. It is also in a gaseous state plus H2. This is a gaseous state. Am I right? Yes. Now what is the concentration here at equilibrium? What you find? 4 minus P and P and P. Now what is the concentration formula Kp? Kp is equal to P into P, 4 minus P. Am I right? Yes. Kp is given my friend, that is 0.04 and value is P square upon 4 minus P. Am I right? Yes sir. What we need to find? We need to find the value, what is the 4 minus P. So first of all we have to find out the value of P. So what to do? We can write here 0.04 into 4 minus P is equal to P square my friend. Clear? Now multiply them. 0.04 into 4, that is we can write here, that is P square. Wait for a moment. First of all let me write down. 0.04 into 4 minus 0.04 into P equal to P square. Am I right? Yes sir. Now the expression will be P square plus 0.04 P minus 0.04 into 4 is equal to 0. Let me check once. This will come here, that is P square plus 0.04 P minus 0.04 into 4. Now you can solve the value of P, and this value when you put here you get the expression here. Clear my friend? Yes, definitely. It's very simple. It totally depends upon the command theory, and for further we can write here P square plus 0.04 P. We can write here 100. Clear? And minus 0.04 into 4 upon 100. What we are going to do here? Equal to 0, that is take the LCM 100, that is 100 P square plus 0.04, that is we can write here 4p and here 4 16, minus 16 equal to 0. So what we are getting here, 100p square, is there any common we can take? Yes, we can take a common 4, that is 25p square plus 2p, plus p minus 4 is equal to 0. Clear? Or we can write 25p square plus p minus 4 is equal to 0, my friend. Now you can easily solve the expression and will get the value of p. So the equilibrium concentration will be, this is I'm moving here, my friend, at equilibrium, that equilibrium concentration is 4 minus p. Let me check once. Kp is equal to p into p upon 4 by p. Kp is 0.04, 4 minus p, 0.04, 4 minus p equal to p square, 0.04 into 4 minus 0.04 p. If it moves here, that is p square plus 0.04 p minus 0.04 into 4, p square, 100 comes here, 100 p square, that is 4p, that is 4 16, okay, 16 here, that is 100 p square, 25 common, that is p square, 25 p square plus p minus 4. Okay, now you can get the value of p. Am I right? The questions are tough, but my friend, it will definitely help you a lot if you have the command over the theory. Clear? Now I am going to rub and we'll discuss the next segment. Now, next one is question number 7. It's very simple. I am moving. Clear? What is given here? The ionization constant given. Ionization constant of HF as SCWH and SCN are 6.8. Okay, that is the value of Ka for HF is given, that is 6.8 into 10 to the power minus 4. Okay, now Ka for HCOOH is given, that is 1.8 into 10 to the power minus 4. Yes sir. And Ka for SCN is given, it is 4.8 into 10 to the power minus 9. Am I right? Yes sir. Calculate the ionization constant of the corresponding conjugate base. It's very simple. We know this conjugate base of HF is, my friend, F minus. We have to find out the equilibrium constant, ionization constant, that is Kb. We know that, we people know, listen carefully, we know that Kw is equal to Ka into Kb. Am I right? Kb is equal to Kw upon Ka. We know the value of Kw, 10 to the power minus 14, and Ka, that is 6.8 into 10 to the power minus 4. This is the first phase. You got the value of Kb of the conjugate base of HF. Am I right? Now let's move to the next one, SCOOH. As we know, for SCOOH, the conjugate base is, that is COOH minus. Is best to write like this, HCOO minus. Am I right? Yes. Now again we know Kw is equal to Ka into Kb. What is Kb, my friend? Kw upon Ka. What is Kw? 10 to the power minus 14. And what is Ka for SCOOH? 1.8 into 10 to the power minus 4, my friend. Am I right? Yes sir, you are absolutely right. This is the second part. What is the third part, my friend? That is SCN. Okay. Now let's move to the next one, HCN. Conjugate base is Cn minus. Am I right? Yes, you are right. Again we know Kw is equal to Ka into Kb. So what is Kb? Kw upon Ka, my friend. And what is Kw? 10 to the power minus 14. What is Ka, my friend? 4.8 into 10 to the power minus 9. You will solve, you will get the answer, my friend. Am I right? Yes, you are absolutely right. These are the things. Now I am giving you few seconds to solve this one. Clear, my friend? Okay. So friend, let's move to the next segment, next question. I think you have noted it down, and it's very easy for you to solve such kind of questions. And as I told you earlier, this chapter is completely calculation based. If you have, again I am repeating, if you have the command over the theory, then you can easily solve each and every question related to this chapter, my friends. So let's move to the next question, number 8. Wait for a moment. Question number 8, that is one part, that is the solution here. The ionization constant for acetic acid, okay, it is given, that is Ka is 1.74 into 10 to the power minus 5, okay. Calculate the degree of dissociation of acetic acid in 0.05 molar solution. That is, the concentration is given 0.05, and what we need to find, the alpha of degree of dissociation. Calculate the concentration of acetic acid ion in the solution and pH. So we have to find also the concentration of acetate ion and pH. Now, very easy. CS3COOH dissociate like this, CS3COO minus and H plus. Am I right? When time t is equal to 0, the concentration is C, 0 and 0. When time t is equal to T equilibrium, that is C minus C alpha and C alpha. Yes. Now, what is the value of Ka? We know that is acetate ion CS3COO minus and H plus upon CH3COOH. Am I right? Yes, sir. Now, moving here, check it out what I am telling, my friend. Now, in this case, what will happen? Ka 1.74 into 10 to the power minus 5, and CS3, that is C alpha into C alpha upon C 1 minus alpha, common C 1 minus alpha. Am I right? Yes, sir. Now, what will happen? C square alpha square C 1 minus alpha. This will cancel this one, C alpha square upon 1 minus alpha. As we know, the base is, the acid is weak. If the acid is weak, then 1 minus alpha will be equal to 1. So, what we get here, 1.74 into 10 to the power minus 5 is equal to C alpha square. What is C minus, my friend? C is given 0.05 and alpha square. So, what is alpha, my friend? Root under 1.74 into 10 to the power minus 5 divided by 0.05. This is the degree of dissociation. Am I right? Yes, sir. Now, we know the next part. What is the H plus ion concentration? That is C alpha. What is C? 0.05. What is alpha? 1.74 into 10 to the power minus 5 upon 0.05, or you can say that is simply the concentration of H plus ion, that is root under, that is K, Ka into C. Clear? It's not an issue. Now, what is the acetate ion concentration? Similar, COO minus, that is C alpha, put the value 0.05 root under 1.74 into 10 to the power minus 5 upon 0.05. Is it visible? Now, this is get acetate ion. Now, next one, if anyone asks you the next part, pH. pH is equal to, we know, minus log H plus ion concentration. Now, this is the H plus ion concentration. Put this value, you will get the value of pH. Look at, very big question, but we can solve part by part. If we, again I am repeating, if you have a command over the theory, you can easily solve the question. Nothing special. Question looks lengthy, but the theory always remains same. Now I am going to rub this part, my friend, and we'll discuss the next question. The next question here, again the numerical part, wait for a moment. What is given? What is the minimum value of water required to dissolve 1 gram of calcium sulfate? What is calcium sulfate? Like this, definitely it dissociate like this, Ca2 plus and SO4 2 minus, okay. At 298 Kelvin, okay, Ksp is given, okay. Ksp is equal to, we know, Ca2 plus and SO4 2 minus, that is S into S, that is Ksp is equal to S square, or we can say S is equal to root under Ksp. Yes, that is S is equal to root under 9.1 into 10 to the power minus 6. This is the case. Now this is mole per liter, that is the solubility. Do you remember Ksp is equal to solubility, that is the mole per liter. Now we have to find out mole per gram. Okay, S is equal to, then we can write what is the molar mass of calcium sulfate. Calcium is 40, sulfur is 32, oxygen is 4 into 16, that is 72 plus 64. 72 plus 64 will be equal to 136. Okay, so S is equal to 136 multiply root under 9.1 into 10 to the power minus 6 gram per liter. Clear? Now after solving, what we get the value 0.41 gram per liter. This is a rough data, you can solve this one, it's so much easy. So we are just predicting the value will be around 0.4 gram per liter. So 0.41 gram in 1 liter. So what is about 1 gram? 1 gram in how many liter? 1 upon 0.41, my friend. This is the answer. Look at 1 upon 0.41. You can solve like this. The value I have written the rough figure, not an exact figure. You can easily solve this one. Put the value in 1 gram, that is 1 upon 0.41, my friend, liter. Am I right? Is there any problem? This is the solubility and this is the solubility product, my friend. Again I am repeating, this is solubility and this is solubility product. If I estimate, then we know 9, the root of 9 is 3 and 10 to the power minus 6 is 3 into 10 to the power 3. That is, now you can write here 136 into 3 into 10 to the power minus 3. 136 into 3, that is 18, 10 and 4, and divided by 1000. So what we get? 0.41. Look at, you can get the value. So it's very simple, calculation part should be strong. So my friend, tell me, is it clear to you? Okay, I think you have written this. Now I am going to wrap this part and I am moving to the next segment, that is the question number 9. What is given in question number 9? Check it out. What is mean by conjugate acid base pair? Is very simple, Bronsted-Lowry concept. Conjugate acid base pair. If I write here HF, the conjugate base F minus. If I write here H2SO4, what is conjugate base pair? HSO4 minus. That is the conjugate acid base pair differ by 1 H plus, 1 proton. That is the Bronsted-Lowry concept. So what is given here? What is the conjugate acid of the following? Conjugate acid base for the following. If I write here HNO2, that is the value is NO2 minus, my friend. Now if I write here Cn minus, what is the conjugate acid? SCN. And SClO4, what is the conjugate base, my friend? ClO4 minus. What is F minus? That is the conjugate acid is HF. What is OH minus? There is a 2 possibilities, that is H2O and O2 minus. Now what is CO3? That is CO3 2 minus, that is conjugate acid is SCO3 minus. What is S2 minus? S2 minus, that is HS minus. Look at the thing, is simple. Yes sir, it's very simple for you. Now this is the question for you. How to solve this question? Tell me. Now I'm going to rub this part. Let's move to the next segment. What is the next segment here? That is the question number 2. This is the solution. The pH of 0.005 codeine solution is 9.95. It is pH given. Yes sir, definitely. That is pH is 9.95. Yes sir, definitely. We know pH plus POH is equal to 14. What is POH? 14 minus 9.95. Clear to you? It is around 4.05. Yes, yes, definitely. Now, what is given here? Calculate the ionization constant and pKb. Calculate is ionization constant. It's very simple. Codeine plus H2O, that is codeine H plus and OH minus. Yes, sir. What is the ionization constant? Kb is equal to codeine H plus. Yes, sir. That is into OH minus upon codeine. Clear? Now, what is OH minus here? That is given here POH. As we know, POH is equal to minus log, pardon, we can write here POH is equal to minus log OH minus ion concentration. Given here POH is equal to 4.05. 4.05 is equal to minus log OH minus ion. In exam, generally they provide you the data, otherwise log comes here and you get the anti-log. Anti-log of 4.05, when it convert minus sign, minus 4.05, you get the concentration of OH minus ion. Put this value. So we'll write here Kb is equal to OH minus square upon codeine. And what is the concentration of codeine? 0.005. Put this value, you get the value of Kb. Am I right? Yes, sir. Now what is pKb? pKb is equal to minus log Kb. Now put this value, you can get my friend pKb. Am I right? Yes, sir. These are the cases related to the question, and definitely, my friend, it will help you a lot. Is there, and again I am repeating, pH given, POH. POH is equal to minus log, minus 4.05 is equal to log. Anti-log of minus 4.05 give you OH minus concentration. Its value is given 0.005. It's an equal concentration. Put here OH square upon codeine. Now you get the Kb, and pKb is equal to minus log Kb. Am I right, my friend? Yes, sir. You can easily solve. Still, if you have any doubt, you can easily approach to me. You are free to do this. Now, read this question. I am not going to help you. It's your turn. Can you solve? I am starting from this one. What to do? Because this is a first formula based. The ionization constant of nitrous acid, it's given is Ka is equal to 4.5 into 10 to the power minus 4. Okay. Calculate the pH of 0.04. C is given 0.04 molar sodium nitrate solution, and also a degree of hydrolysis. Clear? Now, nitrous acid formula, pH is equal to 1 by 2 pKw plus 1 by 2 pKa, remember, and 1 by 2 log C. This is the pH. To find the value, what is pKw? We know Kw is equal to 10 to the power minus 14. So pKw is equal to what? That is minus 14 log 10. Log 10 value 1. pKw is equal to minus 14. Am I right? Yes, sir. pKa given, Ka given, pK is equal to minus log Ka. Like this, wait for a moment. Kw is equal to 10 to the power minus 14, and pKw is equal to minus log Kw, that is minus log 10 to the power minus 14, that is plus 14 pKw. Now put this value pKw here, pKa, that is you can write here Ka, as we know pKa is equal to minus log Ka. Put the value of Ka, you can get the value of pKa. Now C is 0.04, you can get the value of pH, my friend. Am I right? Yes sir, you are absolutely right. And the next part is given here, degree of hydrolysis. Then what is they are saying, that is H. I have given a best derivation to find the degree of hydrolysis. In case of salt solution NH4 NO3, what NaNO3, sodium nitrate, this comes from, my friend, NaOH plus sodium nitrous acid. Calculate the pH of 0.05 nitrous acid and the degree of hydrolysis. Yes, that is NaOH and sodium nitrite, that is NaOH plus SNO2, and it is a salt of weak acid. Yes sir, and strong base. And if there is a salt of weak acid and strong base, this is the pH. And if I proceed further, we get the relation between degree of hydrolysis, because here degree of hydrolysis is represented in K. Big derivation, check out my theory and solve the question. Clear, my friend? Yes sir, you are absolutely right. Now the next one, third one. What will happen in this case? What is the third one, my friend? What is the third one? This is a solubility product. It is one of the simplest question. What is given? The solubility product constant of Ag2CrO4 and AgBr. What is given? Solubility product KSP1 for, just think, KSP for Ag2CrO4 is given here, that is 1.1 into 10 to the power minus 12. Yes sir. And KSP for AgBr is given here 5 into 10 to the power minus 13. Clear? Yes sir. Now what is given here? Calculate the ratio of the molarities of the saturated solution. It's so simple. First of all, Ag2CrO4 dissociate like this, 2Ag plus CrO4 2 minus. Yes. Now this is 2s, this is s. Do you remember how to write this? Yes, 2s square into s, that is 2 to 4, 4s cube. So KSP given 1.1 into 10 to the power minus 12 upon 4, and cube root is give you s. Clear? This is the complete root. Now moving. Now for AgBr, what will happen? That is AgBr will dissociate like this, Ag plus and Br minus. Yes, that is S and S. What will happen? That is KSP is equal to S square. S is equal to root under KSP. What is KSP here, my friend? 5 into 10 to the power minus 13. Wait for a moment, minus 13. So this one is S1 and this one is S2. So what is the ratio of molarities? So the ratio will be equal to S1 upon S2. Put the value S1 and put the value of S2, that is mole per liter. Am I right? Yes sir. Which type of question? Very simple questions. Now let's move to the first one. The ionization constant of dimethylamine. What is given here? Dimethylamine. Am I right? Yes sir. Is 5.4 into 10 to the power minus 4. Clear? Now what to do in this case? Listen, this is easy question, you can do it. Still calculate the degree of ionization. What is given? Calculate the degree of ionization. As we know, alpha is equal to, tell me, root under K upon C. Because we know K is equal to C alpha square. Alpha is equal to root under K upon C. What is K given? K given 5.4 into 10 to the power minus 4 upon C is 0.02. It's so simple, my friend. Clear? Yes. What is dimethylamine? CS3 whole twice NH. Clear? What percentage of dimethylamine is ionized if the solution is treated, if the solution is also dissolved or you can say treated in 0.1 molar NaOH. That is, it is treated with NaOH. So what will happen in this case? If it is treated with NaOH, it will form the CS3 Hall twice NH plus and OH minus. This is the case. And what is given here? 0.02. So the equilibrium is 0.02 minus X, and here is what we get here, that is 0.01 minus X, and this one is X. And what is K? K is equal to, we will write here, that is X into 0.1 minus X divided by 0.02 minus X, that is equal to 0.02, very small quantity, so we put here 0.02. Now this is the expression, and 0.1 as this OH comes from, that is NaOH condition. So what we get? We get the value of X. Suppose the value of X we get is around 1.8 or 1.9, and divide them, we get the percentage of that percentage diameter. Suppose the value of X comes Z upon, that is concentration 0.02. Clear? You can easily solve. The value K is given here, also 5.4 into 10 to the power minus 4, and alpha is also given here. So in this case there is a two part. First of all, you get the degree of ionization we have got. Now percentage, write down the expression, that is, this expression is CS3 NH plus and OH minus, my friend. Clear? It can be written like this. If you have any doubt, CS3 Hall twice NH, this is the case, plus hydrolysis, that is CS3 Hall twice NH plus, and OH minus. Clear to you? Concentration is 0.02. Clear? When we start 0, that is 0 and 0, when time t is equal to t equilibrium, 0.02 minus X, and we get here, that is the value of X, and here is given here 0.1 minus X. Clear? Now K is equal to, we can write here X product upon reactant, 0.02 minus X is almost equal to 0.02. Put the value, K is given, you can get the value of X. This is the case when it is treated, that is 0.1 molar NaOH. Clear? Now percentage ionization, X divided by 0.02, you can get the answer. Am I right, my friend? I think you can easily solve such kind of question, and definitely, my friend, it will help you a lot. I have solved maximum number of questions. I have taken maximum number of questions from your NCERT syllabus. Still, if you have any doubt related to any numerical, you can easily approach to me. I am always free for you. I am always here to serve you, my friend. So my friend, time has come, time to say bye-bye. Thank you so much.